Good morning, class, or any chiefs that might be out there listening to this video. This is going to be a short video on how to fly DME arcs. This is by no means a complex video, so if you're looking for something more advanced, please look for something else on YouTube. This is just a basic overview on how to fly the DME arc. So again, the overview, I'm going to go over some terms that you might need to know, some general steps that you take in order to fly the DME arc, and a simulated example that I'm going to show you guys. So starting off with some terms. So IAF stands for the initial approach fix, and like the slide says, it's the point where the initial approach segment of the instrument approach begins. And it's denoted by the letters IAF on the actual approach plate, as you'll see in a minute. The MEA is the minimum en route altitude, and it is the lowest published altitude between radio navigation fixes that ensures acceptable navigation signal coverage and obstruction clearance. You generally don't want to go below this altitude, as you will you will fail your check ride, and then you may run into any obstacles below you. Then the VOR, which you should be somewhat familiar with, the very high frequency omnidirectional range. It is a navigational instrument used by pilots, and then in the instrument world, it's pretty crucial for some non-precision instrument approaches, as well as for holding. And then DME, just distance measuring equipment that measures your, it's the slant range distance from your aircraft to the DME. And then the fix is a 2D point, which is used for navigation. Okay, so for some general steps. The first step would be to identify the initial approach fix that you'll be flying to and the radial that will take you to that fix. You will also need to identify the DME that needs to be maintained throughout the entire arc and the lead radial that you will turn inbound to. So for this example, I am using the Reading Municipal Airport's localizer DME back horse runway 16, and this I just chopped up the approach plate, so it's kind of why it looks funky, but please bear with me here. So in this approach, you have two initial approach fixes. You follow my pointer here. You have Garza over here, and again, it's denoted by IAF initial approach fix. And you have folds over here, again, IAF. The DME that needs to be maintained can be located at these boxes over here. So for this entire arc, for both arcs, 17 DME needs to be maintained. You have a bit of a leeway. It's 0.5 in either direction, so 17.5 this way, and then 0.5 this way, which would be 16.5. If you go beyond that, you do not meet ACS standards, and you will fail your check ride. And then the lead radial that you'll turn inbound to is right here. It says LR349 or LR334. At that point, once the OBS reads these either or these two numbers, you're going to go ahead and turn inbound to your final approach course. So once those things have been identified, you can proceed to set your nav1 to the VOR that you'll be using as your primary means of navigation, and then your localizer frequency in nav2 as you switch between the going from the arc to the actual approach. Okay, so step 3. So you're gonna fly the radial that leads to the initial approach fix, and upon reaching the fix, you're gonna execute what's called the 5 T's. So the 5 T's are as follows: turn, time, twist, throttle, and tuck. You're going to turn 90 degrees in the direction of the arc. You're going to time the turn. You're going to twist the OBS 10 degrees depending on which way you're turning. You're going to make a throttle or a power adjustment to a specific speed for your aircraft, and then you're going to talk to ATC. So in our example here, let's say we are flying from, just to make things easy, from the Reading VOR on the 028 radial to Garza. So as we're flying along this radial, at 16.5 DME, we're going to make a left turn or a 90-degree turn to the left, which would put us at a heading from 028 to then heading of 298. we would time the turn. So it's a 90-degree turn. Divide that number by 3, you get 30 seconds. It should take 30 seconds. You're going to twist the OBS 10 degrees. We are turning to the left. So you want to make sure you twist the OBS to 018, as we want to be flying on these, or we want to reach the 018 radial, and then that number is slowly going to decrease as we get to 349. Then you're going to make that power adjustment. In my aircraft, our approach speed is about 90 knots, so we want to be somewhere around there ballpark. And then you're going to talk to ATC as necessary. Okay, step 4. This is where people think it's fairly complicated, but it's not. It's just you need a lot of practice with it. So once you reach that initial approach fix, and you make that 90-degree turn, you're going to do what's called the twist 10 and turn 10. So when you reach Garza and you set 018 on your nav 1, once that needle centers, you're going to turn to the left by 10 degrees, and then you're going to twist the OBS 10 degrees. Because essentially what this arc is, you're flying a bunch of straight lines to make it look like an arc. So once it's the OBS centers at 018, then you're going to turn 10, twist 10. You're going to turn to a heading of 278, and the OBS will be 008. Then once that needle centers, the OBS is going to go from 008 to 358, and your heading is going to go from 278 to 268, and that process goes on and on until you get to your lead radial, which is 349. So once your OBS reads 349, you can go ahead and just turn to the final approach course, which in this case is 162. As you're doing this, make sure you keep an eye on the DME. If it's increasing too much, so it's running away from you, so it's going from 17 DME to 17.1, 17.2, 17.3, and so on and so forth, you need to increase your bank angle in the direction of the VOR. So if it's running away from you, you're going somewhere like this, somewhere over here. So you need to increase your bank angle so you can catch up to that 17 DME. And if the DME is decreasing, so it's going from 17 to 16.9, 16.8, then you simply need to decrease your bank angle. So, like I said, upon reaching the lead radial, you're going to switch your navigation, your primary means of navigation, from the VOR to then the localizer frequency, which you have dialed in the nav 2, and then you would simply fly the approach as normal. And I'm going to show you really quickly a simulated example. Okay, so here we are with our little simulator here for the example. So again, we are going to be flying this localizer / DME backcourse runway 16 approach for Reading Municipal Airport. So in this scenario, we are going to be flying over the VOR on radial 028 and flying to Garza, then making a left turn and flying the arc. So I have in my nav 1 the Reading VOR. I have the 028 radial selected. My heading is also 028 because this is a no wind scenario. Obviously, in the real world, you're going to have to account for wind. And as you can see here, my DME distance, here, I'll move it back a little bit. We'll put it at 16 nautical miles. And we'll go ahead and start the simulation. So as we're flying along here, 16.4 DME, we're going to go ahead and make a left turn here, or 16.5, make a left turn 9 degrees to 298. And at the same time, we are going to twist the OBS to 018. Now, as the needle starts to center, once it does center, then we are going to again do that turn 10, twist 10. Okay, so there it goes. I'm going to go ahead and turn 10 degrees and twist the OBS another 10 degrees. And again, our lead radial is 349. So when we get to 349, which is somewhere over here, then we're going to go ahead and turn into our inbound course of 162. Okay, so I'm going to go ahead and turn 10 degrees again. But this time I'm going to add a couple more degrees simply because we're a little bit over 17.5 nautical miles on the DME. And again, we want to remain within 17.5 to 16.5. Go and turn a little bit more. So once again, the needle centered. Now we're going to go ahead and turn 10 and twist 10. And do keep in mind, if you look at the approach plate, your MEA is 5,800 feet. So we are flying at around 6,000 feet. Just do not descend below 5,800 feet because then you might have some problems with obstacles. Okay, I'm going to go ahead and turn 10 and then twist 10. And then we're somewhere around 349, so we can go ahead and start to turn into our inbound course once this needle centers. Okay, so once the needle center, we can go ahead and turn into our final approach course here, so 162. And at that point, we would switch to our nav 1, which is the localizer frequency 108.7, and we would fly the approach as a normal localizer approach. But keep in mind, this approach is going to be a back course localizer,